So we'll talk about gRPC today. We'll see what is gRPC, why we are using it, what is the workflow of gRPC. So let's get started. So before going to gRPC, let's understand what is RPC. So RPC stands for Remote Procedure Calls. It is just like function. So these functions are executed on some remote system and hence the name says Remote Procedure Call. It follows a request response model. A request is initiated from the client. This request is a function call with certain parameters and then the server returns a response. In a real-world example, to construct distributed, scalable, client-server based application, it is used. Now let's get introduction to gRPC. So it is created by Google. So Google Remote Procedure Call, sometimes people call it. It is a cross-platform, open-source, high-performance remote procedure call framework. gRPC was initially created by Google, which has used a single general-purpose RPC infrastructure called Stubby to connect the large number of microservices running with and across data centers for over a decade. In March 2015, Google decides to build the next version of Stubby and make it open source. The result was gRPC, which is now used in many organizations outside Google to power use case from the microservices to the last mile of computing, mobile, web, Internet of Things, etc. gRPC uses HTTP2 protocol for transport. Protocol buffers as the interface design description language and provides features such as authentication, bidirectional streaming, and flow control, blocking or non-blocking bindings, and cancellation and timeouts. It generates cross-platform client and server binding for many languages. Most common use case scenarios includes connecting services in microservice style architecture or connecting mobile device clients to backend services. gRPC's complex use of HTTP2 protocol makes it impossible to implement a gRPC client in the browser. So to use it, you have to use a proxy if you are trying to use it on the browser. Now, gRPC clients and server can run and talk to each other in a variety of environments, from server inside Google to your own desktop, and can be written in any language. So for example, you can easily use gRPC server in Java with clients on Go, Python, Ruby, and in addition, the latest Google API will have gRPC version of their interfaces, letting you easily build Google functionality into your applications. So in this diagram, you can see the gRPC server was created in C++, and any client such as Java, Ruby, Python, Golang, anyone can use it or work with it. So this is the benefit which is not available in case of REST. In case of REST, you need to, if something is consumed in Java, so suppose if you have 4 different API, which one in Java, one in Python, one in Ruby, then a client who wants to connect need to write 3 different implementation for each, because each understand different syntax and each follows different protocols. So how does gRPC works? So gRPC is lightweight binary RPC communication protocol brought by Google. gRPC uses binary as its core data formats. In RESTful services using JSON, we would be sending a string over HTTP. Strings contains bulky metadata about its encoding format, about its length, its content format, and various other bits and pieces. So gRPC workflow looks like this, where we define the protobuf definition, then we compile it with proto compiler, and that generates the code for you. So that's why it is easy to use as well. So and that can be used with Java, Go, Ruby, Python, anything. The code gets generated, and at last we have the gRPC server client which implements this. So what are the benefits? So of gRPC. gRPC offers a refreshed take on the old RPC design methodology, making it interpretable, modern, efficient, using such technologies as protocol buffers and HTTP protocol. The following benefits make it a solid candidate for replacing REST in some operations. First is lightweight messages. Depending on the type of call, gRPC specific messages can be up to 30% smaller in size than JSON messages. Second, it is high performance. By different evaluation, gRPC is 5, 7, and even 8 times faster than REST plus JSON communication. Built-in code generation. gRPC has automated code generation in different programming languages including Java, C++, Python, Go, Dart, Objective-C, Ruby, and more. And last, more connection options. While REST focused on request response architecture, gRPC provides support for data streaming with event-driven architecture. Server-side streaming, client-side streaming, and bidirectional streaming, etc. gRPC is already used in industries by many organizations. gRPC is modern, open source, high performance remote procedure call framework that can run in any environment. It can efficiently connect services and across and across data centers with pluggable support to load balance, tracing, health checking, and authentication. It is also applicable in last mile of distributed computing to connect devices, mobile applications, and browsers to backend services. So many companies, which includes Netflix, IBM, CodeOS, Dropbox, Zalando, Spotify, Uber, etc., are using uh, gRPC. So a typical workflow looks like this, where we have a client procedure uh, to client to call the procedure. Then we have the stub build the message, which is with the message header. And third is the message once built, it is sent on the network. And once it is sent on the network, after receiving, server machine handle the message to the server stub. Then a fifth step is to stub unpacket the message, and at last stub makes local call to get product functions. So in summary, we can say gRPC is modern open source high performance gRPC framework that can run in any environment. It can efficiently connect services in and across data centers with pluggable support for load balancing, tracing, health checking, and authentication. It also applicable in last mile of distributed computing to connect devices, mobile applications, and browser to backend services. Cloud native, Cloud native computing foundation is the new home for gRPC and its existing ecosystem projects. You can visit github.com/gRPC, or you can visit github.com/gRPC-ecosystem. So thank you so much for watching, and if you think the videos are helpful, do like the video and subscribe to the channel.